Hello, everyone. My name is Claudia Ciuca. I am a project officer at CINEA, European Climate Infrastructure and Environment Executive Agency, in the unit Integrated Transport and Urban Mobility. I will be the moderator of today's session together with Thierry Goger from Forum of European Highways and Research Laboratories, and we will have a cluster of 3 projects. The session of today brings at our attention another area very important where research is needed. We will see the preliminary results, as I mentioned, of a cluster of 3 projects that were funded in 2020 under Mobility for Growth, called Smart, Green and Integrated Transport. The focus of the session is on the key element that is part of the overall performance of transport system, that is infrastructure, road infrastructure. The work done by this cluster of projects will contribute to the transport safety on roads, therefore to the goal set by Transport White Paper on the close to zero road fatalities by 2050, and to the sustainable development goals, and not lastly to contribute to the decongestion of roads on infrastructure by increasing the reliability. We want to see at the end of this project that in the near future the research done on the use of robotized equipment, drones, automated or semi-automated piloted solution will demonstrate the potential for the risk of workers' exposure to, in the live traffic or construction machines, the potential to decrease the availability of transport network, and the potential to reduce the cost of reputable tasks and safety upgrades. I will not keep you more. We will go straight to the first project, and I would like to introduce Mr. Pedro Arias Sanchez, professor at University of Vigo in Spain, that will present InfraROB project.
Hello. Yes. Thank you, Claudia, for the introduction. My name is Pedro Arias. I am a coordinator, the project coordinator of InfraROB project. And the project, the topics of the project is gathered in the title, Maintaining Integrity, Performance and Safety of the Road Infrastructures through Autonomous Robotized Solutions and Modularization. Okay, the short project overview about the results. The project is a project for 42 months with 669 person month dedicated to the project, and with a total budget around about 5 million euros. The project consortium is formed for partners from 8 different countries and with different profiles, as is typical in this kind of projects, with universities, despite the University of Vigo, University of Minho, Kohl, and Darmstadt in German, with industrial partners like MOBA from German, RINA, NTS, IPSS, IMC. Another non-profit partners like FEHRL and CC. Finally, last but not least, the owner of the infrastructure is FINAG, is the responsible of the transport infrastructures in Austria. The overview of the project is, we can summarize, like you can see in this slide, is formed for 5 technological areas. And the project is focusing on the roadbed and particularly on the roads paved with asphalts, right? And the project is entailed in 5 technological areas. And the first one is about the autonomous robotized machines for construction, upgrade, and large maintenance interventions. The other technological area is about autonomous robotized machine for routine, periodic maintenance of pavement. And the next one is about the modularization of road construction through industrial prefabricated solutions. In this case, it's a modular safety barrier. And the technological area 4 is for collaborative operations, some safety comms robots with drones for works, zone segmentation and signaling. Finally, the technological area 5 is upgrading of management systems to ensure safer operations and maintenance. And these technological areas are divided in different products or different results, and I summarize here in this slide and in the next one. Our intention is to develop autonomous working road construction train for power, feeder and roller. At this moment, the advance of this task is about 30%. Another objective of the project, another intention is to develop a device for automated laydown of fiber optic sensors during the paving process and to make to the same time, okay, and to try to monitorize the behavior of the paver okay, with the time. Another prototype of autonomous robotized head to repair potholes and cracks. The state of this task is about 40% at this moment. And another one is the autonomous robotized working line marking robot at 10%. And another precast concrete element and safety barrier element, like you can see in the slides, at 30%. And the achievements all the achievements are gathered in this slide. Or another more is about the first is next is about the collaborative operation between safety comm robots and drones for work some segmentation and signaling in areas where the other machines will be working, right? Another task is about the pavement management system upgrade. Into account the robotics, the information that the robotics supply for the system. We are working as well in a digital twin solution for a pavement management system. And last but not least, we are working in a traffic management system upgrade and considering these robotic solutions, this pavement management system, etc. The results we have gathered the results in this modes to make a protection of the results or to put in the market the results. Our first intention is to make a patent of the autonomous paver sensor control system. For intellectual property rights protection, the asphalt can be candidated the asphalt mixture to repair the small potholes and cracks. For the other side, we are developing some products and service to achieve to the market. And we have identified here 4 different products or solutions. The autonomous line marking robot and support, the drone system for monitoring work zones, upgrade the system pavement management system, and the fiber optic solutions for pavement damage detection. The product to the market is a multifunctional precast concrete element, and finally the service to the market, the digital twin based on add-on application. And these proposals is based not just in the characteristics of the product, and as well as considering the interest of the partners that are working in this field, right? The expected impact of the project, we I am summarized this expected impact in main 3 components. Upgrade of management system for decision making, taking into account the introduction of robots or robotics in this field of work. The autonomous robotized solution for work zone segmentation and signaling based on drones. The autonomous robotized interventions and modular solutions. Okay, the impact perhaps can be summarized in these 3 components. As well, talking about figures, our intention is to, according to our proposal and the terms of the call, reduce the fatal accidents at 50%, reduce the traffic disruptions and routine maintenance costs at 20%, and increase the network capacity at 20% as well. And this, our project is according to different politics and priorities of the European Commission, and specifically about these politics, right? And in relation with the smart green integrated transport, our project are developing some solutions for automation, some process, some task. In relation with the Visual Zero, specifically for safety, our project are working on solutions for increase the safety in the areas, in the roads with maintenance works. Finally, in relation with the Digital Europe, our project is working in different solutions based in robots, in automation, in different intelligent management systems, etc., that will increase to the Digital Europe interest. About the expected impact, I have summarized in this slide the impact at this moment. And let me remember you that we are in the month about 18th, right? We have different strategies for communication, dissemination, and exploitation. A website, and this is the number of the visitors at this moment, and the social media with different channels like LinkedIn and another more. The followers at this moment is 330 followers. At this moment, we have took part in different workshops and other activities, plus than 10 activities. In relation with the publications, no scientific, classical publications, we have, at this moment, we made a different 5 publications in local medias and more international journals, right? Talking about the scientific papers, at this moment we have published 5 papers between scientific journals and Congress, like FEHRL, Transport Research Arena, the Road Congress, etc. And of course, we are in cooperation with the sister project in this call, OMICRON and HERON. The representatives are here, and we have several meetings until now, virtual and physical meetings. Our intention is conforming the project is advancing to increase the cooperation and make interchange of knowledge between the projects, etc. That's all. Thank you for your attention.
Thank you, Mr. Sanchez. We will go to the next presentation for OMICRON project. We will have Jose Solid Hernandez, that is coming from Semosa. Should you have specific questions for one of the presenters, we can use the opportunity at the end of the presentation. However, if not, we will use the question and answer session. Thank you.
So thank you, Claudia. So as you said, my name is Jose Solis, and I work for the R&D department of CEMOSA, specifically on the transport infrastructure mobility area. And I am the project coordinator of OMICRON. So today I would like to give you a brief insight on the project. This is the content of my presentation. I will start presenting OMICRON in a nutshell, followed by the objectives, concept, and technologies of the project, and finally with the project impact and the next steps to be followed. Well, OMICRON is formed by a consortium of 16 partners from 7 different countries, multidisciplinary group. We started in May 2021, and we will finish in October 2024, so we are more or less halfway through the project. And let's say this group is formed by research institutions and technology developers working alongside ICT integrators, supported by dissemination, communication, and exploitation experts that aim to provide new services and products to road contractors, civil engineering experts, road operators, and owners within the transport infrastructure of Europe. The main goal of the project is the development of an intelligent road asset management platform. And we divide the objectives into 3 areas. The first one, with respect to technical objectives, we aim to improve and digitalize the inspection activities in roads, as well as to upgrade the safety in these applications and in road personnel. We develop smart road platforms for infrastructure managers alongside robotic technologies and adaptive machinery in order to automate intervention actions. And we also develop tools to support road decision-making, progressing towards predictive maintenance in specific use cases that I will present in the next couple of slides. We aim to implement and demonstrate all of these technologies in European CEF corridors. With respect to environmental objectives, our goal is to support the road sector in the transition set by the European Green Deal, highlighting, let's say, the promotion of asphalt for ultra-thin layers in pavement rehabilitation, and also fostering the use of recycled asphalt pavements. In terms of socioeconomic objectives, in a nutshell, we aim to reduce roads' whole life costs, as well as improving road services and safety, and working on the definition or the supporting to required changes in legislation and or standards. So the concept of the project is shown in this slide, and it is based on 4 main pillars. So we start with, in the left-hand side, with digital inspection, where we develop drones and inspection vehicles connected via V2X communications in order to improve the information that we provide to road users. The second pillar is related to the development of a road digital twin, oriented to BIM and GIS, integrating information from legacy systems and from digital inspection technologies. The third pillar is related to decision making, where we use AI technologies to assess the state of assets in road, and we aim to improve the way in which we perform maintenance activities. And the fourth pillar is related to smart construction and intervention solutions, where we develop a modular robotic platform aided by VR and AR technologies. We develop adaptive machinery, and also we develop a methodology for modular and prefabricated construction. So I will now present the state at which we are in all these developments in the next couple of slides. Starting with digital inspection. We develop a UAV management tool where we integrate multi-UAV inspection capabilities and long-range, low-altitude inspection capabilities in order to improve the way in which we currently perform these inspections. The second point is related to terrestrial inspection vehicles, where we are working on a innovative sensor combination for reality reconstruction. And also we work on the automation of the inspection process of roads, improving the way in which we capture parameters such as SFC or IRI. Finally, with respect to V2X communications, we develop this alongside CITS systems in order to improve the information that we provide to the user. On the second area, with respect to predictive maintenance, as I said, we are working on the development of a road digital twin, which is a BIM GIS-oriented digital representation of roads, integrating all the relevant resources and data from the infrastructure, as well as the analytics and the predictions that we're working on in the project. Thereby, this is closely related to our road decision support tool, where we aim to assess road condition state of different assets and then optimize the way in which we perform maintenance actions. The next area is related to the automation of intervention actions, and in this respect, the first development is the robotic modular platform. So we are developing such a platform in order to perform not just one various ordinary, extraordinary, and emergency intervention actions in roads. And we have some use cases as an example in the project, including safety barrier replacement, safe signaling during construction, installation of cones, sealing of surface pavement cracks, road asset cleaning, or the removal of line markings with laser. Well, and in these two videos, you may see the concept and some preliminary tests that we have been performed. The second point is related to the rehabilitation of surface pavement layers, where we are integrated a set of sensors, including pavement and roller location, thermal control and weather conditions, or pavement surface textures, among others. And the objective is to analyze every step along the paving process in order to provide decision support information to the operators. In this way, we are also promoting the use of greener pavements by using AUTLs and recycled asphalt pavements. The last area related to this robotic modular platform is related to AR and VR. So we work on AR tools for worker support, where we use various devices such as tablets, glasses, etc., to support the robotic modular platform processes. And we also develop a VR platform, in this case for robot tele operation of the robotic modular platform, and also for the training of workers on specific maintenance tasks. In this video, we may see the preliminary test for teleoperation, where we have on the left-hand side virtual environment in Greece, which is moving the real environment in Spain with the robot. The last area I would like to highlight is related to modular construction, in this case, modular construction of bridge overpasses and of a particular type with reinforced concrete elements on the sides and steel elements at midspan. The objective is to enable the use of prefabricates while reducing construction times and reducing traffic disruptions on construction, and thereby improving safety and improving the circularity of the solutions that are currently used in this particular type of bridges. Well, this video is about one of the tests that we have carried out in the project on this solution. Last but not least, we have extensive cooperation with other projects. After the presentation of Pedro, you may see that we have shared objectives with InfraROB and with HERON, as you will see now, in terms of safety, better road services, and cost reduction. And we also have, as Pedro says, a periodic interaction in terms of inspection, robotics, and asset management, mainly. But we also interact with other projects such as ISRIUM with respect to the use of satellite information, which we believe would be a very good addition to the platform that we are trying to develop in Omicron. And finally, we also have close contact with piloting, coordinated by CATEC, one of our partners, on advanced inspection systems with drones mainly. In terms of project impact, this is all subjected to, this is very much related to our demonstration methodology, which is divided in 3 stages. The first one is related to preliminary TRL 4 to 5 testing. This leads to the second stage for technical demonstration of specific technologies from TRLs ranging 5 to 7 in specific locations in Porto, Seville, Guadalajara, and Valencia. And this leads to the final stage, the final demonstration of the whole Omicron platform at TRL 7. Our project impact is based on 4 main KPIs. As you may see, they are very similar to what Pedro presented again. The first one is related to the reduction of fatal accidents of road users and deployed personnel due to maintenance works by 50%. The second one is the reduction of traffic due to maintenance works by 20%. The third one is the decrease in routine maintenance costs by 20%. And the fourth one is the increase in network capacity by 20%. To conclude, I would like to provide what are the next steps of the project. So we are currently continuing in the technology developments in terms of sensing, robotics, digital twins, decision support systems, etc. We have a next, let's say, milestone as we have a next general advisory board meeting approaching. So we have, let's say, an open and dynamic concept for external advisory board. We have meetings more or less every 6 months. The next one is on the 31st of May of this year. So if you are interested and you want to know more about the project, please don't hesitate to contact me or the external advisory board chairman, Jesus Rodriguez, as let's say this is a dynamic and open group, and we have online sessions for those that are interested. Let's say the technology developments and the feedback from this external advisory group will lead us to the low TRL demonstration starting from August 2023. And this will also lead to the final demonstration at TRL 7 in April 2024. And the end of the project is set at October 2024 with evaluation and exploitation analysis of the project. Thank you very much for your attention. I would be very happy to answer any questions in the round table.
Thank you, Jose. If there are no questions, specific questions at this point, I would like to invite the third project represented by Nicolaos Bakalos, researcher at the Institute of Communication and Computer Science from Greece. Thank you.
Thank you very much. Similarly to the previous two presenters, I'm here to present the HERON project, which is the third project presented in this session. And HERON stands for Improved Robotic Platform to Perform Maintenance and Upgrading Roadworks. A little bit about the project. We're running for 48 months. We started on July 2021 and the finish is on May 2025. Our budget is a little bit under 5 million euros. We have a consortium of 12 partners from 7 different countries. And as you can see here in the graphic there, we are similarly to InfraROB and OMICRON, our sister projects, we're on the execution, let's say, side of the maintenance procedure, working on output from other previous projects. So what we're doing in HERON in a nutshell, we are targeting very specific maintenance and upgraded procedures. We are focusing on sealing cracks, on patching potholes, on the rejuvenation of asphalt, the replacement of replaceable urban pavement elements, repainting of road markings, and we also want to support both the pre and post-intervention phase by developing technologies for visual inspection of the maintenance to increase the awareness in the pre-intervention phase, and also with dispensing and removing traffic cones for isolating the area of intervention, and then after the intervention is executed, bringing it back to normal operations. To do that, we need to develop quite a lot of things. We start with the robotics platform. We start with an unmanned vehicle that needs to be integrated and have all the necessary tools to actually perform the maintenance procedures. On this robotic platform, we need an optimized control framework where the robotic arms and other tools are being handled. To achieve this, we need to establish specific sensing and communication capabilities. Essentially, we need to be able to see what's happening there and correlate our sensing data with the control framework. And to do so, we're developing an AI toolkit to increase the situational awareness from the sensing data to actually perform and create some characteristics and find out what we're doing beforehand. This is right now the main where we are the project. We are developing this stuff, but to actually perform our integrations, we need to establish the communication architecture. We need to be able to establish service provisioning on site through proper communication channels. And also there is the visualization elements. So we are also developing a decision support system and an incident management system. Both of those are going to support VR and AR elements for the maintenance procedure. And finally, we're targeting an on-site integration because the output of the project, similarly to OMICRON and similar to our other sister projects, is a TRL7 demonstration. So we need to be integrated and actually perform the demonstrations on site instead of the laboratory. So a little bit about the achievements of the projects up until now, and we start with the robotics platform. First of all, we have developed and integrated on an unmanned ground vehicle a number of different mapping algorithms, such as RTAB-map, LEGOLOM, and others. And those mapping algorithms are tuned to accept both the robot odometry and have been tested using cameras. And we are also developing a 3D mapping structure that is combined with obstacle avoidance models. So we are developing technologies where we can efficiently maintain a 3D world space and move around it, and also configure a robot to avoid obstacles on 2.5D there, not a full 3D, let's say, aspect. Currently, we are adapting the UGV to actually support our use cases. Obviously, because we have additional tools on the robot, we need to have additional electrical support to power the tools. Because we need to manipulate the robot beforehand, we are developing exchangeable modules to support all the planned interventions. And obviously, we are mounting the robot with multiple camera sensors and other types of sensors, such as depth sensors, LiDAR, etc., in order to make sure that we can use the robot and move in the maintenance area. We are on the simulation stage right now, but right now in the project, we're performing stability simulations for the robot. Moving on to the robotic arm and controlling the robotic arm. So right now we're providing a low-level control control platform for the robotic arm. We have a pipeline which focuses on tracking the performance and stability with variable loads. And also we are adapting different sensitive devices and strategies in order to increase performance. And we are assigning basic actions for motor drivers on the robot arm and the low-level actuators. We are doing this in order for the robot arm to be able to essentially do a lot of the interventions and perform a lot of the work needed for the interventions. We are seeing here the robotic arm actually trying to patch a pothole, let's say. So we see on the left-hand side how we can spread things using the robotic arm to actually patch the pothole. And the final, let's say, technological pillar of our achievements has to do with both the sensing and the relevant AI and deep learning modules to understand what the sensing data show us and to increase situational awareness. So we have established we have extended object detection methods to identify in real time what areas of interest for our project, so potholes, cracks, road markings that have been blurred. And we see there that using camera mounted on dashboard mounted cameras, we have quite excellent performance. We have extended this for visual inspections through drones. Obviously, as the distance the distance increases, the performance lowers, but we're still able to identify quite a lot of things. And we can do this pretty much in real time. So we can see here an original video from a dash camera, and on the left-hand side, we can see the object detection methods and identifying all the different areas of interest. This is happening in real time. This is not post-processed, let's say. This can happen actually in real time for the object detection part. But beyond identifying a general area of intervention, let's say through the object detection, we need to actually extract information about the geometry of the issue. So we are also proceeding in the developing of some segmentation algorithms. We can see here, I'm not going to go into too much detail, technical detail, but we can see here how specific architectures are performing for actually not only identifying the area of, let's say, a pothole, but actually targeting this pothole and identifying the entirety geometry of the pothole. The same thing happens for road markings, for cracks. So we're actually developing deep learning models to essentially be able to track all those things and assess what is happening on the road, both for the pre-intervention phase, for the planning, let's say, of the intervention, and also during the intervention to identify whether what we did was okay and whether what's the status of our intervention. So regarding impact, we have, let's say, two different, we can see impact in two different granularities. For the midterm, similarly to our sister projects, we aim at a reduction of exposure for the maintenance personnel. We think that the sensing capabilities that we are developing can increase the preparedness and can allow the robotic arm platform to at least initially act as an assistant to maintenance personnel. We are also targeting a reduction in traffic disruptions due to maintenance. We can use what we're developing for faster execution of maintenance actions. We can increase the situational awareness in the planning phase and know exactly and have exactly the intervention plan before we're actually executing it. And we can also use the robotics platform, again, as an assistance to maintenance personnel. And what is the long-term impact, let's say, of HERON? And I believe this is the same for our sister project as well. We are targeting very specific interventions that they might seem small in the beginning. Patching a pothole might seem like a small intervention, but at scale, we think that this is actually quite helpful because we can continuously monitor the road infrastructure through the technologies that both HERON and InfraROB and OMICRON are developing. We can schedule the maintenance procedures beforehand in order to not have issues with the traffic, disrupting traffic. And we can, this way we can increase the road infrastructure life cycle and also minimize accidents. That's it from me. So thank you very much for your attention, and I will be happy to answer your questions in the following session. Thank you.
Thank you very much for the last presentation. Just a few words before I give the floor to Thierry. These are 3 research projects in a cluster, and all of them, as you can see, target and address very specific and targeted aspects. Our midway and our research projects, the TRL level at the end will be TRL 7, and I do hope that already catch your attention, and I do hope that you'll have plenty of questions to ask. Now I'll give the floor to Thierry to moderate the question and answer session. Thank you.
You. Or maybe we'll probably stand up. Good morning, everyone. I think that there is no need for the moment to make a summary. I will do it afterwards. But probably we can start first by, let's say, opening the room or the question time. So do you have, first of all, clarification maybe for the speakers? Silence doesn't mean that everything is clear, but it means at least that there is a hope. Yes, thank you. One, and then yes.
Hi, good morning. Thank you for your presentations. This is Alejandro Lanuza from the TEDx, and I was wondering if you have had a look into the business model or studied the business case of these applications.
I believe that maybe, yeah, the question is for everyone, so yeah, who wants to start first? Yeah, please. Yeah.
Yes, so thank you for the question. So from the perspective of Omicron, let's say we have, as I said, 4 targeted areas: inspection, predictive maintenance on 2 sites, and then intervention and construction and retrofitting. So let's say the inspection market has been studied. So we are focusing, let's say, on automation via drones and via enhancing how we capture information from terrestrial vehicles. And we believe this is a big market, and it has a lot of potential. With respect to predictive maintenance, perhaps it's more incipient, but it will make true changes once it is fully implemented. So we talk about a lot about digital twins and decision support tools and stuff, but in the end we have to narrow it down to specific use cases in order to have specific applications in order to be able to put them into production. And with respect to the application of robotics, the approach in our project was to have a platform that could do, as I said, not one but many intervention actions, that so that there was a business case that was not targeting just one very small application, but any or many extraordinary, or emergency intervention actions. So yeah, that's more or less what I can say on my side.
Thank you. Okay, according with the comments of Jose, in our case, our project, the main focus of the project is to develop solutions to solve the problems around the maintenance works in roads, right? You must consider that is a research and innovation action, right? Then the final TRL of the solutions must be about 7, more or less, right? Then it's important, the business models, and it's important as well, but it's not the main issue at this moment of the project, right? And in our case, we are in the month 18th, and in our case, this issue will be studied in the advance of the project, in the solution, when the solutions are more close to the final, and considering the state of the solutions, and in this case, I guess, is the moment to analyze the possibilities to achieve to the market and considering another alternative solutions, etc., right?
Yeah, from my side as well, it's the comments are similar to what Jose and Pedro have mentioned. We are quite early in the project to have established very specific, at least, exploitation plans. But at the same time, we have some plans to basically to inform the technological development procedure. So we do not, let's say, have business plans of how exactly the platform that we're developing is going to be exploited by our partners or by other institutions in the future. This happens usually when you have, the established solution, and we are still in development mode. But we are taking into account all these aspects when we're developing, just so that we have a modular system that can be integrated in different areas, that we can, as Jose mentioned, do the necessary maintenance procedures, to maintenance interventions to actually address specific market needs. So this is the plan. This is the status for HERON. We have plans that are mainly now informing the technological development, let's say, rather than actually the business plan aspect of the project.
Thank you very much. I was invited to sit, so now I see the room from a different angle. Yes, please. Yes, sorry, yeah.
Thank you. Good morning, everyone. My name is Sergio Escriba. I'm head of sector in CINEA, working together with Claudia and the unit of transport research. My field of working now is automated transport. So my question is directed to that point, because those machines that you are presenting are really automated vehicles as well. They are big machines that will be working together with the passing vehicles in roads that are under operation. So there is somehow similar risks of, I don't know, false maneuver, loss of control of the machine. going on that direction, there is a lot of work in the automated vehicles sector on the security of data, avoiding hacker attacks to the vehicles. I would like to know if in your project you are considering as well some cybersecurity measures to protect the machine from external attacks.
So who wants to start first? There are probably two aspects: cybersecurity on one hand, and also somehow the software that stopped working well, and then the vehicle does not make the right maneuver. Yeah.
Can I start?
Yeah.
Okay. So regarding the cybersecurity part, let's say, we have we're currently starting working on that in the communication, let's say, because we need to establish the communication infrastructure, both for cybersecurity issues, but also for service provisioning issues, because obviously what you are doing, and this comes back to also the safety, the actual safety. Usually the problems are that at the edge you do not have the computation capabilities to actually make that much informed decisions, rather when you have access to servers and to bigger computational machines, let's say. So we're establishing the communication interface both for the service provisioning part, but also for this communication, let's say, stack, where we're also taking into account exactly cybersecurity issues and encrypting, let's say, the data that we are gathering, especially when we are, because the plan for all the project is to continuously monitor the road. So essentially, the knowledge there is that we are going to have a very detailed idea of what the road is going to be when this is actually implemented on real-life scenarios. Regarding the security, the actual security of personnel, of the traffic accidents, stuff like that, all three projects, I think, we have very specific KPIs for reducing traffic accidents. All of us, we are also doing, if you saw one of the common characteristics, I do not want to talk for other projects, but we are all dispensing traffic cones, we are all isolating the area beforehand. I would say for HERON, the biggest aspect that, in my view, is going to have an impact on security is the planning phase, is that we can actually using drones, using cameras, have a very clear idea of the intervention, and we can plan it when we do not have that much traffic flow, so there is a lower possibility of accident. We can plan it and do it fast, so we do not essentially disrupt that much of the traffic flow, and minimize the time of the intervention, which essentially all those things, I think, minimize the probabilities of accidents.
Yeah. Hi, Sergio. Okay, in relation with your question, let's say a couple of things. The first, in our project, we have identified two different levels of communication, right? The first one is the communications in the local place, the communications between robots, between machines, the communication of the power machine with the cone robot systems, etc. Then at this level, I guess perhaps the possibility for external attacks is lower. But however, our other level of communications is between our systems, our solutions with the traffic management system that there is in the road, right? Like in the case study that we will apply our solutions. In this case, the risks of external attacks is higher. It's true. At this moment, with the develop of our project, we are solving the problem to solve the problem of communications, the best way to solve the problem of communications between the TMS with our solutions, because we have a lot of problems to solve in relation with the security that the ongoing TMS that the infrastructure are using, they have a lot of barriers, a lot of problems to solve to access to them. This is the first issue. And to be honest, at this moment is not at this moment of the development of the project is not the best problem for us to think about the external attacks. But it's sure that in the future we must consider this potential problem.
Yeah. So thank you, Sergio. I think you already identified the next area of research for maybe future calls. Thank you. Yeah, indeed, this is really an important aspect because we can see that the development for the moment is more in the, let's say, is almost in let's say, or independent from the rest of the traffic and the rest of the say, the different environment. There is another question. Yes.
I'm Sam Altarzi, Süleyman Demirel University from Turkey.
Yeah.
And I'm happy to be here because of this, more related with me. And I'm looking for the civil engineering side. And this project is very important information for us. Actually, we need some additional information about that. And we have a lot of distress, not only crack and pothole, and a lot of distress type. If you works about that, and the other distress type is, I'm very happy about that, and I have to learn that. And the other side, I'm working about the payment management system, and this information very important for payments management system. But our aim is the need estimation of the payment performance. And do you have any plan to payment performance? And for example, payment condition index, payment serviceability index, or international roughness index, something like that. And we need the information, what's the plan next? And when we have to maintenance to road, and we would like to learn that. And we have to cost-benefit analyze, and we have to share the budget to road. And if you have a plan about the other steps and your project about that. Thank you.
So thank you for your question, and we're glad that you are interested in the area. Well, in this respect, I invite you to follow our external advisory boards, in particular ours that has an event soon. With respect to, let's say, the condition analysis and stuff from the perspective of Omicron now, I can say that we tackle it in two ways. First one is more on the sensing side. So we, as I said, we develop UAV capabilities, multi-UAV capabilities, and long-range, low-altitude capabilities in order to improve the way in which we capture reality. In this respect, we are focusing more on all assets but pavement, okay? Then, with respect to pavement, we focus more on the terrestrial inspection vehicles, on improving the way in which we capture defects, potholes, cracks, etc. But this is not only it. We also are working on specifically what you mentioned on the computation of parameters such as IRI or SFC. The objective is to improve the way that this is currently being done, and to control, let's say, that these processes are measured in a consistent and standardized way, because as you know, depending on how the vehicles are placed and stuff, results may differ. So this is what we are focusing on now. This is with respect to sensing. Then with respect to taking action on what we have sensed. As I said, well, we work first of all on the integration of information on a digital twin, on a GIS BIM environment. In this respect, for linear assets and linear registries, more even on the GIS side. And we also work on the process of this information in order to provide, let's say, intuitive information for the road operator, so that they can make decisions on specific sectors of the road, that would yield, let's say, cost optimization, service optimization, service improvement, and also take into account the carbon footprint that the repairs that are going to be made have on the management. So these are, let's say, things that are being developed. So we would be very glad to provide more information in the couple of months.
Thank you for the question. It's very interesting for me and is very relevant for our project. Okay, you must consider the main topic of the call is not to make a prediction of the behavior of the assets of the road, right? And the best or the most important component of the call, the most important question is to solve how we can robotize solutions for maintenance, etc. Despite of that, in our project we are including fiber optic sensors and to make a control of the evolution of the pavement. But however, we have not a specific task for make a prediction of the or foresee the behavior of the asphalt and these issues. This information will be an input from our robots, from our solutions, but we have not dedicated efforts in person months to this prediction or this kind of things, right? Thank you.
Yeah, very similar comments from our side as well. So regarding the sensing, I've showed a couple of results for our sensing. We can do right now. We can do quite well object detection, so we can identify specific issues. For HERON, we are focusing on very specific interventions, and we feel that we need to focus on this to actually create workflows that work extremely well in unmonitored conditions, let's say. And to do this, you need to start very specific. But for the sensing, let's say, apparatus, the models can be easily extended to have additional, let's say, to identify additional objects or other incidents. And we are also, we have a very specific task of geolocating the sensing data. So we are not only creating we are not only identifying the objects and where the issues are, but we are very specific on not only on the local scale, but on the global scale of things. And similarly we are also developing incident management systems, decision support systems to actually showcase the results. But we are not for the prediction of what's happening in the road infrastructure currently. At least this is not under the purview of HERON as well. We are targeting very specific maintenance interventions rather than having a more life cycle assessment, let's say, and predictive capabilities for life cycle assessment of roads.
Very good. Is there another question? Yes? Please, yeah.
Hello, Ilias from the Joint Research Center of the European Commission. Thank you for your presentations. I have a question I saw on a slide by Jose, V2X, and I was wondering to which degree all vehicles are increasingly connected and they have sensors of all kinds, to which degree they can complement this technology and render them more attractive by the sense that they can replace some of the actual devices.
So in this respect, I can go a bit more into detail on what we do on V2X in the project in order to clarify. So what we, as you know, these projects are heavily focused on maintenance actions. So what we try to do is to provide connecting to connected intelligent transport systems, we try to provide further information on the state of the road and the state of traffic to the user. In this respect, we are working on providing various information such as, well, apart from weather, traffic, etc., also where maintenance vehicles are, where there is an accident or where there's some emergency intervention actions being taken place, which is then interesting or is then relevant in order to have smart routing or smart, let's say, management of the traffic around a particular area in which maintenance is taking place. So the approach for Omicron in this respect, our, let's say, step beyond what is currently done is to connect maintenance management to traffic and to improve the information that the driver and the road manager has on the table, basically.
Yeah, please continue. Yeah.
I was thinking something more of the other way around. When a car goes through a pothole, I'm pretty sure that even the smartphone accelerometer will get this information.
Yeah.
It would be interesting for you to capture this information.
Yeah, for sure. I mean, that's, let's say, exactly the other way around. And for sure, it is interesting in the end. You gather a lot of, you may gather a lot of information from just the vehicles passing by and, let's say, sensing what is actually going on, whether there's a pothole or there's a congestion area or there's a, well, crack would be a bit more difficult, but you may sense all this information via accelerometers, cameras, whatever, and this may feed back to the maintenance contractor. So yes, definitely, it's a very interesting area of research.
This very interesting topic that you arise, and is very interesting, not just thinking about this project. It's a research area with a lot of interest. But in my short experience, the main barrier about that is to access to the data of the cars, right? And it's normally is the access to this information is very restrictive and is difficult to access and to download or another process with this information is complicated. The owner of the car normally protect this information, I think it's not in an open way. But it's very, very interesting.
Good. There is also another question.
Yes, Eleanor Lesquin from CINEA. I just have a question about collaborative robotics. I don't know if you explore this specific kind of robotics. And do you explore also the interest of HMI, advanced HMI, to support road workers?
Who wants to start?
I can start. Yes, so in Omicron, we use, in certain use cases, we explore collaborative robotics. For instance, one of the videos I showed is on the replacement of safety barriers. So in this respect, the idea is to have the robot to put the safety barrier, which is long and difficult to manage, to a certain position. And from that point, the road operator actually interacts with the robot in order to place it in a particular, in the right position and then use it. So there's that degree of collaboration also via VR and AR, as you may see in the slides that I showed. And let's say it is an area that very well joins with enhance HMI. So at this point in the project, we are actually starting to develop these HMIs. And yes, we are building on previous experience, but right now we are at the first stages on this, and we think it's a very important point.
For HERON, so regarding the robotics part, this needs to happen quite a lot, especially when you need to, even before in the sensing stage, let's say, of the intervention, you need quite a lot of collaboration between different unmanned vehicles, because a lot of times, especially when we are talking about drones, drones are not really, it's not really easy to integrate multiple sensors on small drones. So you might need cross-modality information, and you might need collaboration in the way that these drones, let's say, move, in order for you to get multimodal information about the asphalt in the planning stage. And obviously during the execution, based on different workflows, you might need multiple vehicles deployed to dispense the cones and then patch the pothole. So we are doing quite a lot of collaboration between different robots, both from the ground and also having information from drones informing what's happening in the ground vehicles. Regarding the interfaces, we are also developing a decision support system where, with AR and VR capabilities. We are not really focusing our research on HMI aspects. We are developing the interfaces, but it's something that we do for visualization, and we're not really we're developing the front-end interfaces, but we're not really do research on the HMI aspects, at least in HERON.
In our case, in the InfraROB project case, we will work with collaborative robots in the sense of the machines, the paper machines, will work in collaborative mode with the cones, with the robot cones, right? Because our intention, at the same time, they will work with the drone. The drone will gather information of the environment and transfer this information to the central platform, and the platform will know the position of the different cones and the position of the machines for paper and these things. And our intention is all the robots are moving at the same time, right? And considering the restrictions for safety about the distance, the minimum distance with the border, or with the for cars at moving, etc. And this is our plan to solve, and it's true that we need to work in this way, okay, with a collaborative robots to know the position and to give signals to move, etc. Right?
Well, is there any other question? Yes, one. Yes, just in front.
Thank you for your presentation. My name is Tao Mei from Carlos III University of Madrid. And my question, because I'm working on the area of traffic information, traffic management and control. So my question is something about traffic conditions. For your opinion, or maybe for your experience in your project, how can you assess the data of traffic management systems? I mean, for example, in which channel you get the information or communicate with these systems? And in your robot or in your system, who do the evaluation of traffic condition? The robot or your system, or you just believe or you convey the information that you get from the traffic management system?
For HERON, the road operator is actually the one who has all the information. So the robots do not assess traffic per se, but with the sensing that we have, we can, through the interfaces that we're developing, we can essentially give all this information to the manager to take the decisions. We are not integrated with traffic management systems, let's say, at least for the project. Obviously, when this is deployed when this would be deployed in real life scenarios, all these things would need to be integrated. But for right now, we are mainly focusing on, first of all, sensing, to understand what is happening there, and then deploying the robots and establishing very specific maintenance procedures to fix very specific things. The decision of when this is happening, the assessment of the traffic, of how we can this affects traffic, goes back to the operator, and there's not a decision that the system at least makes. Some suggestions are going to come through the decision support system, but this is not going to be integrated, at least in HERON.
Yeah, you want to add something else? Yeah.
Okay. Sorry. In our case, in the InfraROB project, before we talk about the inputs of our project, must be the information about the state of the pavement, etc. But in this case, the output of our project will be information for the traffic management system, right? And the traffic management system must be considered the information that our robots and our systems are supplied for the system, and to organize and to take a decision about how the traffic must be organized, right? Then the results of our project must be the inputs of the traffic management system. I don't know if I am giving answer for your question.
Yes, I think that's the point. My question exactly is, how can this data be the input? For example, real time, or just as a report or something? How can you do that?
Just to finish this. In our case, it's in real time. It's sure. Yeah.
Okay, thank you.
I mean, just to complete from the perspective of Omicron, it's more or less same as what my colleagues have said. Let's say we could be providing information, but within the project we do not work so much on the connection to the traffic management system, apart from certain use cases, following a previous question on V2X, where we try to integrate the information from the maintenance and also from traffic flows in order to provide more information to the user. But currently it's not the main area of research of our project, but it is indeed an interesting area to be explored in the future.
Very good. So I think we can have maybe one couple of last questions. I've seen Sergio. So Sergio, please.
Thank you. I have many questions, but let's...
well, a set of questions. One, okay.
Yeah. All the three projects aim to finish at TRL 7. Next steps could be going closer to the market, but for that, you know, Thierry, we need a pull from the industry. We really need to be sure that there is a need. In other words, these systems that are, in principle, quite expensive compared to the current practice manual work, would require high investments from road operators, from construction, maintenance companies. What are the benefits that you can offer them? How would you convince them to put their money from their own pockets to continue and finalize the development of the techniques and make them a reality?
If I may just add one compliment to what he said, is, you know, it's linked to your impact, promised impact in a way of 20% routine maintenance cost in a way. So all this is all in whole. So if you can elaborate on that.
So when you consider there are two main pillars, let's say, that I would consider in this. The first one has to do with essentially, obviously, when we're developing prototypes, the cost is quite high. But especially transportation is really the field where it's really evident that when we industrialize this, so when we have a product that, okay, it should do very specific things and it should be on TRL 9, this means that it's done that, and it also has considered cybersecurity issues, it also has considered HMI issues. But when you are doing this on a more to scale, let's say, granularity, the costs come down quite significantly, come down by orders of magnitudes sometimes. Also, we have so actually performing maintenance, it's quite expensive for a couple of reasons. First of all, because usually, at least in my experience, we're not really deploying something for fixing one pothole. You are doing it in larger areas for larger issues. So this affects traffic because you need a mass of issues to actually have a financial benefit for actually performing the intervention. And also you have quite a lot of costs for traffic disruptions in this case, because this would take more time, and you need to deploy quite large number of people to do them. I think that in HERON and all the robotics that we are developing, we can have a really, the return of investment, I think it's quite fast if you consider, first of all, the industrialization part, that we are obviously bringing the cost down, and the development of the prototype is not the same as developing the actual product for the market. And also because when you are doing targeted interventions in smaller scales, you do not need that much crew, you do not need that many people, and you do not need to disrupt the traffic for that much time, especially when you are doing it in a robotic manner where you can do it at night. You can do it, not during rush hour, which is not the case in at least what's things happening today, because you are actually closing the road or closing lanes for hours or days or weeks to actually do all the stuff, because things pile up to actually have issues with and deploying personnel.
Maybe before the other one prepared their answer, we had a level of complexity. Could you please try to identify where are the, let's say, the percentage of gain? Like you mentioned clearly, there would be a reduction of number of people working, of workers. And so, on the contrary, the machine will also work faster. So, on all in that, do you have an idea of, let's say, all this contribution to this cost reduction that you are mentioning? You all mentioned, by the way, in the 3 project. That would be really like going in the more precise direction.
Well, in this respect, well, first of all, going with Thierry, I believe it depends on precisely on the area that we tackle. Well, precisely in OMICRON, we go from inspection to execution, so it's quite specific to the action and the task and the current amount of workers that you have on a specific site for, I don't know, replacing safety barriers or putting cones and stuff. What I wanted to do is to add on what Nicolas said, that I believe it's a common goal for the 3 projects, which is safety. Safety is, as you said, as you may see, one of the impacts that the 3 projects aim to tackle. So I believe the increase in safety on a particular workplace and particular workspace is one of the, let's say, added values that these 3 projects can bring to the to a particular road manager or road contractor in order to pursue or use the solutions that we are providing. Once this is said, again, costs are very important, and at some point, well, currently, obviously, at the development phase, costs are large, but I believe as we are trying to industrialize, let's say, repetitive tasks and tasks that can be more or less controlled with robotized or automated technologies, I believe cost at some point, analyzing specific use cases, may come down. And I believe there's for the 3 projects there's from now onwards, and we are already on it, a very important area of the research, which is building on the business models and building on how these technologies and where can be particularly applied and provide, let's say, some addition to what it's currently done.
Thank you very much. So we are approaching slowly to the end of our session. You see, we had 1 hour of discussion. Sometimes it looks very long at the beginning, and eventually we are 3 minutes before the end. Maybe just before we conclude on the session, I'd like just to have a quick reaction from each of you about the expected impacts. So you focus them on fatal accident, you said 50% reduction, traffic disruption 20%, maintenance, let's say, operation reduction in terms of cost by 20%, and this would save up 20% of network capacity. Coming back to the question which was raised earlier about the performance of the infrastructure, so it can be pavement, it can be the structure itself. Maybe there is one critical, let's say, impact here which is not mentioned, or at least criteria, KPI as you want to say, is about does this automated or / robotized, both together, work as good as the human being at the moment, or can they help working better? So basically, could you foresee, let's say, an impact there in terms of performance of the infrastructure thanks to the robotization, the automation of the maintenance? And there, you know that there are a number of challenges related, for instance, for asphalt, lay down and so on, with degree and so on, temperature to be kept. So could we expect that maybe with the robotized, with the robotization, with automation, this could enhance and foster in a way let's say the optimization and the performance? So my question or comment was long, but the answer should be fast, although I think it would have been also very interesting to speak about that in a longer time. So maybe one quick word from each of you on that, please.
So from our side, I think the answer is yes. I think that we can, the unmanned robotized systems, whatever, the hybrid model is going to be, it's answering a question. We're trying to optimize very specific workflows here. So we're trying to optimize very specific repetitive tasks. And technological development has shown that when you have an actual workflow and you have very specific targets for that workflow, automation is quite easier. When you are going in the wild, a lot of things can happen. So we believe that both in time, both in cost, the traffic disruption, I think, is something that speaks for itself. I think that when you have all the flexibility of deploying these solutions whenever you want and doing it very targetedly, the traffic disruption speaks for itself. But when you optimize those workflows, this becomes cheaper, this becomes faster, this becomes more resilient, this becomes more, the performance is really increasing when you have a clear idea of what exactly you need to do and do this task very specifically.
Jose, a bit faster if you can.
So yeah, I will just add that I truly believe with respect to inspection and sensing, we go beyond what's currently being done. With respect to robotics, I think we need more time. We need more time, as Nicolaus said. And but I think it will come after time, as you said.
To finalize from my side, we are on time. The critical issue for me, under my point of view, is how we can integrate all this information, right? And if this information is well integrated and is, if we all this data can works together, then the solution will be fine and will be achieve this impacts, right? But it's not depend of just the individual solutions. It's not critical, and in my point of view, is how we can put together and working at the same time.
Very good. Thank you. Thanks to all of you, and I think we can give you a big round of applause for this great project. So, to conclude, I think you all have seen the situation in France, the discussion about the pension. When we see this potential for the productivity thanks to the robotization and automation, we may hope to live in pension maybe by the age of 50 in the future. So with that, let's go for the next session. Thank you very much.